purpose of this training is to help you understand retrofit strategies beyond simple lamp and ballast replacement. Providing an effective, energy-efficient lighting solution for your customer that goes beyond simple one-for-one replacements will set you apart from your competition. Offering this concept to your customers often results in increased sales for you while providing customers with a better long-term investment. Typically, we approach a lighting upgrade with narrow tunnel vision, looking at what is there now and how to save energy with a simple one-for-one replacement of either lamps and ballasts or new fixtures. But why not think of the space as a new construction and strive to provide recommended light levels to each space? The benefit could be more sales for you and more savings for your customers. The key elements include meeting Illuminating Engineering Society (IES) minimum recommended light levels, using less energy per square foot than existing energy code lighting power allowances, and installing controls not only where required by code, but in every possible appropriate location. This is merely taking the same design approach used to meet energy code and going one step further, saving even more energy. Let's begin with light levels. As addressed in previous session, the primary function of lighting is to provide the appropriate light level and uniformity for the task to be performed by the people occupying the space. The IES Handbook 10th edition contains a listing of recommended light levels, ranges based on the type of task being performed. When we talk of light levels, it is important to understand that we are talking the average level within the space. While the light level directly under a fixture will be higher than the level between fixtures, maintaining a certain level of uniformity is important. A good rule of thumb is not to exceed a ratio of more than 3:1 between the highest level and the lowest level within the space. However, in a fine dining establishment or high-end retail, general uniformity may not be a goal since the light levels at the table would purposely be different than other areas and might even be served by a single candle. Considerations in setting the target light level include such things as speed required to perform the task, the size of the task, and task difficulty. Recommendations are provided for most facility types or space types, from banks to bars and receiving docks to restrooms. Meeting the minimum light level recommendations will help those occupying the space perform the typical tasks conducted in the space. Even within a space, different light levels may be appropriate. 10-foot candles in the lobby of a bank may be sufficient, but higher levels are needed by the teller window where they are conducting paper transactions all day. Consideration for the age of those performing the task is also necessary, as older occupants need higher light levels to perform the task. Depending on the task or facility, different approaches may be required to most effectively achieve the desired results. Assembling large pieces in an industrial facility, like an airplane manufacturing plant, requires a high level of general lighting, which might be best served by high bay lighting fixtures. On the other hand, assembling small pieces of electronic equipment may be best served by a lower general lighting level and a second source of lighting located closer to the work being performed, known as task lighting. Similarly, museum lighting might be better served by a low level of ambient lighting, complemented by accent lighting on individual art pieces. Once target light levels are established, you need to know the lighting power allowance, LPA, and the applicable energy code. LPA is expressed in watts per square foot. An example, an LPA of 1 means that the actual lighting power density, or LPD, cannot exceed 1 watt per square foot. Decreasing this allowance by 10% would result in an LPD of 0.9 watts per square foot, saving your customer even more energy than a project meeting code. To learn more about light levels and lighting power allowances, Northwest Trade Ally Network offers a more comprehensive in-person training on Beyond One-for-One, available to all members. In order to realize a better-than-code design, it is important to remember the components of a lighting system. To find the lamps and ballasts, or LEDs and drivers, with the best efficacy, the simple formula is total lumens divided by total system wattage, which equals the lumens per watt. The higher the number, the better the efficacy is. To determine direct luminaire or fixture efficiency, we look at the ability of a luminaire to deliver the light out of the fixture. Not all fixtures are as efficient as others, even in the exact same style of fixture. Most fixture specification sheets will show you the fixture efficiency as a percentage. The percentage represents the total amount of available lumens that actually exit the fixture. Fixture efficiency can range anywhere from the low 60s to the high 90s. The higher the efficacy of the light source and the more efficient the luminaire, the fewer fixtures we need, or we can use fewer lamps per fixture. This allows us to go beyond lamps and ballast and design better than code projects. Incorporating controls in all applicable areas saves even more energy. The deeper savings from a better than code approach provides opportunities for you to set yourself apart, increase sales, and provide the best effective energy efficient solution for your customers. Northwest Trade Ally Network lighting specialists are available to help you determine the appropriate light levels, applicable codes, and to help you find solutions for better than code design. To find additional resources, the latest news, and to access the list of upcoming Northwest Trade Ally Network workshops through the region, visit www.nwlightingnetwork.com. That's nwlightingnetwork.com.
You've just completed Module 3, Basics of Retrofit in Place. Please consider viewing the additional 4 modules in Northwest Trade Ally Network's Basics of Energy Efficient Lighting video series. Module 1, an overview of energy efficient lighting in the Pacific Northwest. Module 2, Basics of Energy Efficient Lighting. Module 4, Best Practices for Site Audits. Module 5, Utility Lighting Calculators.